Hi everyone, it is Miss Rapp. We are working on Algebra 2, Unit 6 polynomials, and we are working on Lesson 4, factoring and factoring by grouping, pages 63 to 67. Let's get started. Okay, so let's review factoring. So step 1, look for a GCF. I see that I could pull out an x from all of these. So I get 10x squared plus 3x minus 18. So now I'm going to use the area model. I want to multiply to negative 180 and add to 3. Those numbers are going to be 15 and 12. The 12 is going to be negative. Okay, let's use the area model. This is 10x squared. That's going to be negative 18. This is 15x, and that's negative 12x. So I could take out 2x from here and 5x from here. And I could take out 3 from here and negative 6 from here. So I end up, when I factor it, I get x, 2x plus 3, and 5x minus 6. So when I set them equal to 0, I get x equals 0 for the x in the front. I get x equals negative 3/2, and I get x equals 6/5. Cool. Pause the video here and try the rest. So here, I'm trying to multiply to negative 72 and add to 1. So that's going to be 9 and 8. And the 8's going to be negative. I'll draw the box much bigger this time. 6x squared, negative 12, 9x, negative 8x. Let's find the sides. I could take out a 3x here and a 2x here. I could take out a 3 from here and a 4 from here. So I get 0 equals 3x minus 4. This is going to be a negative 4. And 2x plus 3. So I get x equals 4/3. X equals negative 3/2. Okay, try the last one on your own, and then I'll show my work. Okay, so I learned from Unit 5 that I'm going to take out a GCF, and this becomes a perfect square trinomial. So I just know that I don't even have to draw the area model for this. I can just go 10 divided by 2 is 5. So I know if 5 multiplies to 25 and adds to 10. So the x equals negative 5 is the final answer. Okay, so let me grab my graphing calculator really quickly and graph all these for you guys. Okay, so here's x plus 4. 4 is the y-intercept, up 1 over 1. The number of solutions is 1 because it crosses once. Okay, let's do the next one. X squared minus 5. That crosses twice. Let's try the next one. X cubed plus 3x squared minus x minus 1. That crosses 1, 2, 3 times. Let's try the last one. X to the power of 4 minus x cubed minus 4x squared plus 1. 1, 2, 3, 4 times. So what is the pattern? Will it continue forever? Let's talk about this. The fundamental theorem of algebra. This is like what we've been building up to all year. So yay. If f of x is a polynomial of degree n, where n is greater than 0, then the equation has exactly n solutions. So degree 1 has 1 solution, degree 2, 2 solutions, degree 3, 3 solutions, et cetera, et cetera. So we define solutions right here. So like, because this is multiplicity 2, it's 2 solutions. Because this is multiplicity 5, that's 5 solutions. Because this has a plus or minus, it's 2 solutions. So it doesn't mean that's across that many times. It's just we define solutions with lots of different things. Okay, let's move on. How many solutions does the following polynomial have? Well, this is degree 3, so 3. This would be 5, and this would be 4. If we want to be able to find the solutions to these functions, we need to be able to factor all types of polynomials. If there is a GCF that results in a trinomial quadratic, we know how to do that. If there is no GCF before separate terms, we are going to factor by grouping. So I'm going to show you guys with the area model. I think it's the fastest, but there are other strategies. If you check the answer key, there are 2 strategies. So the area model has 4 boxes, and there's 1. So guys, same rules, first and last go here, and there's 4 boxes, so you can actually find them all here. We went over this in quadratics briefly. So now we'll just factor the sides. This is going to be an x. This is going to be a 5x squared, because that's the GCF of these. And over here, I'm going to take out a 6. And over here, I'm going to take out an 8. So I get 5x squared minus 8, and x minus 6 equals 0. So I'm going to set them each equal to 0. 5x squared minus 8 equals 0. And I'm going to solve for x, so I'll add 8, 5x squared equals 8. Divide by 5, x squared equals 8/5. Take the square root. And I get x equals plus or minus 8/5 square root. That's one of our answers. And then the other answer is just x equals 6. So it was degree 3, and there are 3 answers. 2 answers, 1 answer. Okay, let's try the next one. First, let's see if there's a GCF. There is nothing I can divide all these by, so I'm just going to start with the box. So this is 10x cubed, that's 14. Those are the rules, those have to go there. Otherwise, that's how that works. So this is going to be a 5x, and this is going to be a 2x squared. Because 5x times 2x squared is 10x cubed. This is going to be a 2, and this is going to be a 7. So I get 5x plus 2 times 2x squared plus 7 equals 0. So I'm going to set them each equal to 0. This is going to be x equals negative 2/5. And this one is going to be a little more involved, a little more complicated. Divide by 2, x squared equals negative 7 over 2. Normally we would say no solution, but we know better than that now. We get x equals plus or minus I root 7/2. Okay, let's try the other examples. Okay, so here are our last 2 examples. I'm going to look for a GCF. I do not see one. So I'm going to start by doing the area model. Negative 63, 7n cubed, negative 9n squared, 49n. So I actually like this better than quadratics because you don't have to do the 8 times c that adds to b. This is going to be 7n. This will be n squared. This will be 7, and this will be 9. Yeah. So that's going to be a negative 9, positive 7. So I get n squared plus 7 times 7n minus 9 equals 0. So this is going to be n equals 9/7. That's one answer. We're going to have 3. And this Well, minus the 7, so I get n squared equals -7. I take a square root, and I get n equals plus or minus I root 7. Okay, let's try the last one. So these all have a v, so I could factor out a v from them. And they're all even, so let's see what else. I believe I can factor out an 8v, so I get 0 equals 8v squared, actually. So that's going to be 7v squared minus 61v plus 40. So now it's a quadratic, so I have to draw the area model for this. So I'm trying to multiply to 7 times 40, which is going to be 280. And I'm trying to add to -61. Take a moment, try to find values that work. It's going to be -56 and -5, -56, -5. So I'll draw the area model for this. So 47v squared, -56, -5v. So this is going to be v. This is going to be 7v, because 7v times v is 7v squared. This is going to be -8, and this is going to be -5. So here's what we have so far. We have 0 equals 8v squared, v minus 8, 7v minus 5. This is degree 4, so we're going to have 4 answers. So this is going to be v equals 0 with multiplicity of 2. So there's 2 of our degrees. This is v equals 8, and this is v equals 5/7. So we have all 4 answers. Awesome, good work, guys. Make sure you're practicing your factoring. Knowing your multiplicities and your times tables are going to be really helpful right now. So write down any questions, make sure you do the video check-in, and have a great day.